Welcome to Academic Guru's Tutoring Tuesday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Tuesday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos.
Alright, so in this video we're going to tackle a derivative problem. It says f of x equals e to the x to the fourth power minus x. Here we have e raised to the power of x to the fourth minus x, and we need to find the intervals of increase and decrease of f values for which f has a local extremum, and the intervals of concavity and inflection points. Okay, so let's get to the first part of our problem. Again, in order to get the answer, in order to find the areas of increase and decrease, we need to take the derivative of our function. So let's do that. So we're going to have derivative f prime of x equals, we're going to leave the first part alone, so I'm going to have e to the power of x to the fourth power minus x times derivative of x to the fourth power, whatever I have as my power, minus x. And now we're going to have, let's see, we're going to leave the first part alone, so we're going to have x to the fourth power minus x. And then here we're going to have, so we're going to have 4x, it's going to be times 4x cubed. We're going to drop the power by 1, and then x turns into be negative 1. Alright? Now, we already know that e cannot be equal to 0, so we're not even going to worry about that. But we have 4x cubed minus 1 equal to 0. We can't set that equal to 0, so we're going to have 4x cubed minus 1 equals to 0. And then again, we're going to move the negative 1 to the other side. So we're going to have 4x cubed equals positive 1. And then we're going to divide both sides by 4. So 4 and 4 cancel out. So we're going to have x cubed equals 1 over 4. And again, in order to get the x, we have to take the cube root of both sides. So we're going to have cube root, so we're going to have, let's see, so this turns into be x equals cube root of 1 over 4. Okay, and based off of our previous problem, this was our minimum. Okay, so for our local extremum, we're going to have rad cube root of 1 over 4. Okay, x equals, and for the intervals of increase and decrease, remember we draw our number line. We had cube root of 1 over 4, cube root of 1 over 4 in the middle, and this side was negative infinity, positive infinity, and it happened to be negative positive. So pretty much we're going to have our interval of decrease to be from negative infinity to cube root of 1 over 4. And for our increase, we're going to have from cube root of 1 over 4 to positive infinity. So cube root of 1 over 4 to positive infinity. Okay, so let's get to the third part of the problem. So it says find the intervals of concavity and inflection points. So again, we need to take the second derivative of our function. So we had f prime of x equals e to the power of x to the fourth minus x times 4x cubed minus 1. Now we need to take the second derivative, and this is pretty much where it gets a bit confusing, but it's nothing too complicated. We should be able to do it just fine. So second derivative, we're going to leave the first part alone, so we're going to have e to the power of x to the fourth minus x. We're also going to leave the second part alone, so we're going to have 4x cubed minus 1 plus, again, we're going to leave the first part alone, so we're going to have e to the power of x to the fourth minus x times whatever we have inside our parentheses, excuse me. So 4 times 3, we're going to get 12. Then we're going to drop the power by 1, so we're going to have 12x squared. Okay? Now again, if we look at our derivative, let's see, this we have e to the power of x to the fourth minus x repeating twice, so maybe we can factor this out. So we're going to have prime of x equals, let's see, we're going to factor e to the power of x to the fourth minus x, and we're going to have 4x cubed minus 1 times 4x cubed minus 1 plus 12x squared. Okay, and from here let's combine stuff together. So we're going to have derivative of x equals e to the x to the power of fourth minus x times, so we have 4x cubed minus 1 times 4x cubed minus 1, so this is going to turn out to be 4x cubed minus 1 squared plus 12x squared. So again, e to the power of 4x to the fourth minus x, this part cannot be equal to 0, so we're not even going to worry about that. And now we need to expand this part and set it equal to 0 and find the answer. So we're going to have, this is a large one, so we're going to have 16 x to the 6th power minus 8 x cubed plus 1, negative 1 becomes positive, and then we have plus 12x squared. And I did this on my calculator and I didn't get any real zeros, so this is not equal to 0. Ultimately we're not going to have a real solution for this problem. We're not going to have a real 0. So for our inflection, point of inflection, we're not going to have any point of inflection, so I'm just going to write none. And based off of this, we can just say that our graph is concave up. Let me write it actually. Okay, never mind. Let's just write it here. So it's going to be concave up, and it's going to start from negative infinity to positive infinity. Negative infinity to positive infinity.
Thank you for tuning into our Tutoring Tuesday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Tuesday, happy studying.